Hello, I'm Tom Butts, Content Director for TV Tech and your host for today's webinar entitled MXL in Action, Real-World Interoperability for the Software-Defined Era, Part 2 of our webinar series on MXL. In Part 1, a week ago, my colleague Jenny Priestley, Content Director for our sister brand TVB Europe, led a discussion about the architecture and capabilities of MXL with the BBC's Peter Brightwell, as well as representatives from Appear, Riedel, Matrox, and TELUS Alliance. Today, we will be speaking with representatives from Grass Valley, Riedel, TechX, and TVU Networks about the potential for MXL to revolutionize how media is produced worldwide. We'll kick things off with a keynote from Helio Eufrazino, Media Solutions Specialist at TV Globo. During today's panel, we'll discuss the impetus behind the development of MXL, as well as explore real-world implementations of MXL, which could greatly enhance interoperability between devices, systems, and workflows, enabling more agile, scalable, and efficient production operations. First, though, a little bit of housekeeping. So you'll notice that there's a chat tab that you can use to say hi. You can also use it to reach out to the TV Tech team if you have any technical issues during the session. But we often find that a browser refresh should get rid of any technical issues you will have. I also want to point out that we have subtitles available in multiple languages, no less. Just click on the CC button to add, and you can select from a variety of languages. And there's a Q&A tab if you want to ask any questions to our panelists. We really encourage you to do so because we have some very knowledgeable experts on this webinar, and I really think you'll gain a lot from asking them questions. We'll take those up in the last 10 minutes of the hour. And if we don't manage to get to your question today, we will try and follow up after the webinar. So without further ado, let's dive right in. First off, I want to introduce our esteemed panelists. Adam Marshall. Adam is the Chief Product Officer with Grass Valley. Mike Cronk, who is the Vice President of Strategy for TVU Networks. Drew Martin, who is Head of Video Product Management for Riedel Communications. And Russell Trafford-Jones, who is the Industry Engagement Manager for TechX. And to start things off, we have Helio Eufrazino. I'm sorry if I butchered your name, Helio, but Helio is a media solutions specialist with TV Globo, which has really taken MXL by the horns, and it would be very interesting to see how TV Globo is approaching MXL. Helio?
Thank you so much for the opportunity, Tom, and all the people here. We have here a lot of friends in order to talk about this webinar. How can we say about MXL? Let me give a comparison, but not being so nostalgic. SDI is a very good format. It's a format that we can say that we are multi-vendor agnostic. We can have a multi-vendor scenario. We have a lot of very good protocols and video and audio. We can have a very high quality, and at the same time, it's very easy to handle. When we bring the solutions for ST2110, the transport protocol, we have the same thing with hardware-centric solutions, but not with a software-centric scenario. MXL can solve some questions that we have regarding some issues that we can see with the software-centric solutions and the computing scenario that we have right now. But let me bring the presentation. Let me do all we want to do. This is the agenda that we have for this presentation. We have here a very short description of the live production at the Global, a POC that we have a multi-vendor scenario using a similar approach of MXL, the pillars of this POC, and about the conclusion and software-centric needs. Let me give first a scenario from Global. Global is a very good company, a company that has 60 years of this broadcast industry. And we have here all these phases, the fixed, the hardware equipment, the software-defined hardware, of course, the hardware-centric scenario, and we are moving to a software-centric environment on public and private clouds. Speaking more about global, we have more than 30 PCR, more than 30 production control rooms. 2 of them are connected to the cloud. We've been studying cloud environments with live production since 2020. Our first on-air production was in 2021. Talking about the video, mostly we have our formats in 1080i, speaking about the video, and at least once per week, we have a 4K production. This is a scenario that we have more than 200 daily hours of productions, and we need to enlarge these systems. Why? Besides all the stuff that we have during the daily hours, we have now a new terrestrial television system. It's called DTV Plus. This system brings us a necessity to have more production 4K, more production 1080p. But here we have an interesting issue. Usually, guys, we can see the SDI infrastructure and ST2110 infrastructure. It can handle very well with the hardware-centric equipment. The first 2 columns of this slide. But when we combine the computer solutions with the transport protocols that we have, we can see some small issues. During all this time of this industry, we have some mentors personally for me that can explain me more about the MXL and the other solutions that I can say as media fabric solutions. One of them is Daniel Robson from Matrox that could be bringing some information about what is the difference between the MXL and the other transport protocols. The first thing we can imagine is the MXL is not a protocol. Is a SDK, is a way of transferring live audio and video asynchronously, not with synchronous transport protocols such as ST2110, NDI, or whatever. And another guy, Vincent Tussar from Grass Valley, inspired me to have this sentence in this slide. ST2110 is a combination of a billion of small packets and a delivery at a fixed rate. This combination is not good for the computing. We need another glue, another way of transferring asynchronous media among the vendors. And it's important, guys. When I see a multi-vendor scenario, we need to transfer this audio and video live, but not using synchronous transport protocols. And what you can see about the issues when we do the transport protocols using computing, sometimes we can see some small effects, some freezing, some discontinuity on the signal. MXL can solve this problem because it can use the best of the computing can do in a synchronous way. Instead of using the mechanism that we are showing with the transport protocols, we can see an asynchronous way to transfer a big amount of data with the accelerated process. I have to say, guys, that when I saw this at the first time, I could say something. There is a common saying in Brazil about St. Thomas, one of the Jesus apostles. that says something that we need see to believe. Because for me, at the first time, to say, oh, you can use this transferring live audio and video media asynchronously. For me, it didn't make any sense in the beginning, but I could prove it using a POC of a lot of vendors, a multi-vendor scenario with a solution similar to MXL. This is the POC diagram, the POC diagram that I showed to us right now. This is a scenario that we needed to bring it at a public cloud environment. We are using AWS in São Paulo, Brazil. And in a way of sending the signals to the cloud and having it back, we could do a scenario with a SRT signal flow. And inside the cloud, we have this multi-vendor scenario using Neton Live as a video switcher, Drastic technology as a waveform, Matrox being like a heart of the system, and InSync as a frame rate converter. Matrox origin can bring to us something that is called AMF, Asynchronous Media Framework. It's a way of shared memory for uncompressed live audio and video. And carrying this live audio and video across the system in a way intra-host or inter-host. It's very similar to the principles that we have in MXL. So great, let's prove it. Let's see if it works well. The first part of this POC, it was the quality check. So, firstly, in order to see if the signal is visually good, we bring a scenario with live sources from the ground to cloud and having back using this SRT encoder decoder, and the response was very good. It was visually good. There is no stuttering using a scenario similar to MXL. And in order to check the quality, I have a scenario using like a file reference inside the cloud, using Neton Live to play a signal, passing through the system, the entire signal, using all the parts of Matrox origin, and having a very light visual mixer to consume this signal and having back to a recorder. So at this point, we have two files, and we did a comparison, an objective comparison, using LCard video quality estimator tool. And the response was good. The PSNR and VMAF, we can see that the signal flow is comparable to studio production. So very nice. So we did 2 steps and thinking about MXL and this way of asynchronously transfer the audio and video through the system, it was nice. But the last one, the latency. How can I say about the latency? Of course, when we see a SRT signal flow, we can get a couple of frames or a couple of seconds of latency. It's usual. But instead of seeing just this point, let us see if the latency inside the AMF, inside the infrastructure on the cloud, we can see if the latency is good. And all the operations that we could see with the Matrox platform and Neton Live platform was good. There was no noticeable latency when we switched something. When the switch among the sources, it was fine. And we could see any kind of other problems. No, I could pay attention that the signals among the flow, among the entire infrastructure, we could see that they are fine. We have the same latency in the input and having the same latency in the output. Comparing the signals and this slide, we can do this comparison. We put the same signal on the 4 different SRT encoders and could see that the final latency is the same. Great. So we could compare the latency, compare the quality, and what about the multi-vendor scenario? Yes, we could prove it. We could prove it that a media fabric like AMF, we can switch the signals inside the cloud and distribute these signals perfectly. We can tell that is a very similar approach scenario that we have in SDI. And this is a concept that a very good broadcaster, and we have here a lot of good broadcasters, they wanted to achieve. But of course, we have here some kind of boundaries. We needed to have some kind of boundary components capable to convert the traditional transport protocols to MXL, as we show in the slides. But just remembering, MXL is just a part of the process. In the DMF reference architecture, you can see a lot of layers. When we talk about MXL, we are just seeing the green part, the green layer. We needed to talk much more about the other layers. We have to see the application UI, we wanted to see the provisioning, the container platform, the infrastructure, all the concepts and all the principles that we have in DMF. But when we talk about what we expect about this scenario, when you see the POC had a limited number of vendors, but it was very fine. And we can see in the future like a big interop POC. We are planning to have more components involved, more production resources involved. A vendor from audio mixer, video processor, instant replay, playout, graphics, in-encode, all of them connected together the same infrastructure using a kind of media fabric in a asynchronous way to transfer the live media from a component to another. But of course, speaking of global, we wanted to see this with more protocols. Besides SRT, we want to do this with mainly SCT 2110, JPEG Access and NDI, audio, we needed to bring Dante, Ravenna. Is a scenario that we have here at the Global. Mostly our infrastructure uses this kind of protocols for the IP core, but we can bring these signals to a different infrastructure, software-centric. Maybe in the future we can have something like this, an infrastructure being software-centric, using this asynchronous way of transferring that is called MXL, and the rest of the infrastructure using hardware-centric scenarios, using production switches, audio mixers, and other parts of this production in the hardware-centric way. Maybe a feasible ecosystem that we can mix both scenarios. But expecting more about the MXL or expecting beyond MXL. Since remembering some slides before, we've been studying this scenario since 2020. So we could see that the software-centric solutions are good. We've been proving these solutions on air for our tier 2 and tier 3 scenarios. But how about to have it to tier 1, to top premium products that I have? Speaking of all the guys here that are American, how about to have a software-centric scenario producing a Super Bowl final? Besides the same quality of SDI, ST 2110, if the system is reliable or not, if we have the ultra-low latency, of course, MXL, this asynchronous way of transferring media, will achieve this. But besides this, beyond this scenario, we need to have the other two columns. We are doing software-centric. We are going to a scenario that is different than the broadcast that you have in traditional way. You have machines. We have operating system. So we have to do a DevOps by design. We have all these principles. We needed to achieve all these principles. To have the orchestration, to have stateless scenarios instead of stateful. We have to do containers instead of lift and shifting. We have to do a security foundation. And of course, who will support all this stuff? When we have these two scenarios, the two columns, probably we will achieve the third. We will do in the future scenarios that we can see. We'll have a production that is very smaller, use a kind of machines connected together or alone, making some kind of production tiers. And of course, instead of using big and very heavy machines, using small ones in a horizontal scaling, being connected by this special and new scenario that it has MXL. So this is the guys we want to share about how can we achieve with MXL in contrast that we have right now using transport protocols and a software-centric scenario. Thank you guys for the time. Tom is with you.
All right, thank you, Helio. That was a very comprehensive overview. Can you tell us what's next? What's on the horizon?
As I said in the slide about the round 2 of the POC, we wanted to share more production resources inside it and planning, and about the end of the year have like a prototype capable to cover a medium live in production event. Maybe a news program, maybe a soccer game, something that we can have to prove that we can cover a certain time, a certain type of event that we want to produce. And of course, looking for 4K or at least 1080p 5994 instead the actual in the current scenario that we are using 1080i.
All right. Well, thank you, Helio. Thank you. It's a great presentation. I'd like to bring our other panelists on board, and want to ask each one of you. I'm going to start with Adam. What does MXL mean for you and your organization?
Yeah, good question. So first of all, thanks for having me. So I think Helio kind of touched on it a moment ago. SDI and SIMS 2110 and other linear standards have been brilliant for interconnecting systems, which are disparate hosted solutions. But as we're moving to a more software-defined world, and obviously what we're doing with AMP in the background, or in the foreground even, having multiple applications from multiple vendors all running on the same block of compute If we had to use those linear standards, it's just not efficient. It adds encapsulation delay. It doesn't work in a way that computers work, which is in blocks or chunks of processing. So MXL really allows us to work at the raw memory level. So Hilo, you were calling out the emphasis on latency and quality there. That is exactly what MXL provides you in software defined, because it allows you to read and write that raw memory down to TempFS storage, and all applications have direct access to it with the same GTM standards you have with other tools. So MXL, just to be clear on that one, is effectively the evolution or the next step of what we have in our memory share technology with frame cache. And many of those on the call here, we're working together collaboratively on really co-developing that as an open SDK, so that it makes that interop much easier between vendors and ultimately makes it easier for customers as well.
All right, thank you. Thank you, Adam. Mike, you're next. What does MXL mean for you guys at TVU Networks?
Well, we're very excited about MXL. TVU has been doing shared memory, efficient transfer of uncompressed video within a computer, between computers, for about 10 years, using like Linux 10FS type of technology that's fairly standard in the IT industry. And we've done a lot with that, but the exciting thing is, and obviously, like, Grass Valley, this example, has been a leader in kind of using that technology as well. But the actual format of the bits was different between the companies, because you just invent something, right, independently. And so the exciting thing about MXL and the open source initiative is everybody's going to have a common way of doing it. So it's interoperability, really. The rising tide lifts all boats. And then you get the benefits that both Elio and Adam articulated, which is really the compute efficiency. When you think about software-based live production, you're paying for the software, but ultimately it's that how many compute cores do you need? How much storage do you need? That's where the price tag goes up. And because it is so much more efficient than doing all this effectively needless work in terms of packetizing the bits, that MXL is really, it's going back to the first principles of video and computers and how they work together. And so we can be more efficient. And that then those two things, interoperability and efficiency, are two key components of unlocking this whole area for the industry.
All right, thanks, Michael. Russell, what's the word from TechX?
Hey there. Thanks for having me. It's great to be here. For us, MXL is a way of propelling things forward, because we're doing all sorts of things at the moment in the cloud, software based, and there's an ultimate problem. Like any broadcast infrastructure, one way or another you can get on air, right? But time and time again, we're seeing people making compromises, and they don't want to make those compromises, and we don't want them to make those compromises. But fundamentally, there are some times when you have to do that. And one of those is the lack of MXL. And so for us, we're really interested in making sure that we've got a solid foundation MXL wise to build not only tomorrow's workflows, but literally the ones that we're already operating today using other technologies, pushing things together. So, we can talk later perhaps about all of the benefits and the promise that is there. But it's as much about tomorrow as it is about today.
All right, Russell. And Drew, tell us about Riedel's approach.
Yeah, so Riedel's always been about open standards, 2110 and MOS. We've helped drive those standards and implement them in our products. We've been working behind the scenes on similar type technologies. When the EBU came out with the DMF spec and we saw that MXL on there, it greatly aligned with what we were already working on. So it's something we're helping to drive with Grass Valley, with everybody else that is on the team to really make this interoperable solution. But it is the next phase. After you go from IP, people started using COT servers, and now you're using COT servers who want to get more efficiency out of those COT servers. So having these vendors all work together to make an SDK and not a standard, so that other people can integrate with it without having to go through all the hoops and jumps that you have to do when it comes down to other protocols. I think it's very important for Readle to be a part of this and for our future products to be handling it natively.
Thanks, Drew. I think you kind of answered my next question in terms of, why is it not a standard? And I think part of it is the openness. Also, part of it is also a time situation. Are we on a time crunch into getting this integrated? What is there a rush out there? I'm just going to throw this out there. What is the time element on this?
I don't think there's a rush necessarily, but I think there's a natural evolution of where we're all developing as a group of vendors, and there's the market demand for these software applications, multi-vendor kind of solutions. Frankly, the longer we wait until we have a defined kind of model in place, the longer we get, as you say, Mike, everyone does their slightly different things. I think the really cool thing here was that from its conception, so MXL was what? IBC 2024 discussed on the show floor as hey, wouldn't this be great, with the CBC Radio Canada team kind of instigating that, look guys, let's get together on this. It took just over 12 months, or 13 months effectively, and to get to release candidate on, what was it, Christmas Day, guys? And the really amazing thing there was it actually worked first time. There wasn't a long drawn out process. I know that sounds really honest perhaps, but there wasn't a long drawn out process where we spent years writing standards, to your point, Drew, where we all got together and implemented our different ideas, and then we actually came down to implement it. And like some other standards out there, we've all done it slightly differently, and you've got to kind of wander around those interop labs. Whereas the interop with MXL, we all turned up about, 2 weeks before IBC 25, we spun up our applications and it just worked. And you saw that across a number of the kind of demonstration booths on the show. So I think the rush is more about us wanting to make sure that, frankly, from a vendor perspective, we all invest in the right space and we all work collaboratively together. And secondly, ultimately, this is needed for the market to really accelerate that move to a software-based future, I think.
And I would say the rush is implemented because we're using more modern software development processes like GitHub, and being able to collaborate across different vendor spaces, checking code, talk to each other, communicate much better than it has been in the past. And that's why an SDK is so important here. And sorry, Mike.
Yeah, no. I would say I'll talk about why there's the rush, and then there's why there's the no rush. And the no rush is people are making television today just fine. But underneath that, people want to provide more content to generate more revenue and do it more efficiently. And there's cost precedents, with rights deals going up and up and up and those types of things. And so the promise of what we can do with software and elastic compute is immense. We did a study, like a 20 camera soccer match type of show, standard pricing on AWS for EC2. For 90 minutes, it was less than $15, which is just mind-boggling. And so there's this tremendous potential economic promise, but you have to have the right quality, you have to have the right latency, all those things that Elio talked about in terms of DevOps. It's really total cost of ownership of running that production, how to get my people, equipment, and software cost in the zone where it's very efficient and extremely reliable with the right quality. When we hit those marks, then there will be a rush because people just grab it up. It'll be such a much better way to do it. I don't think we're all the way there yet, but that's the promise, and that's why we're all so excited about this, because we believe collectively we can deliver something amazing for our customers.
I'd just like to add to that one of the benefits of the way we're doing this is as an open source project. And we've all seen projects which kind of wither and die, and there's great benefits to open source, but if you don't get the project right and you don't have enough contributors, then it doesn't really work. What we've done is we've got a whole group of people, hopefully continuing to grow, who are really interested and excited about what we're creating. And that feeds everybody. It feeds the interest of the developers. It feeds the ability to talk and keep the interest of the industry. So in effect, the traction that we got at IBC and before is really important. And not only does it show us that we're in the right direction, but by keeping up the urgency, so to speak, we actually magnify that effect, and that really benefits the whole project.
All right, thank you, Helio. I know you addressed some of this during your presentation, but can you elaborate a little bit on what you see as the biggest challenges right now in adopting an MXL protocol?
I think, guys, that the most important is to see how we can use it, the machines that we are doing right now, that we're having right now, with this new technology. And of course, we are anxious to have this ready very, very soon, because in order to move it to software-centric scenario for a 4K production, I think it's the biggest challenge for me, to have this amount of the signal coming from a solution for another. But of course, to have more vendors involved, because we have to have the best solution for each part, the best solution for the production switcher, the best solution for the audio, instant replay. We want to choose more. This is the concept of the multi-vendor scenario that we were talking about. And I think it's a challenge in this point, to have more people involved. It is, of course, it's something, of course, that you, the vendors, are trying to achieve in order to bring this to the customer.
Thank you, Helio. You kind of helped me pivot to my next question in regards, when I've seen these presentations on MXL, one of the things I find, people say, I want to pick best of breed. And I'm thinking, wow, does this mean the death of end-to-end solutions? Probably not. But how does this change how you approach, and I guess one thing I want to ask is, what kind of feedback have you gotten from customers over this time in terms of, I want to pick best of breed, I don't want to be locked into a system? Adam,
I think all customers want to be best of breed and don't want to be locked into a vendor. I think that's, if you're an engineer and you're locked into one vendor and then that vendor has problems, then you got to diversify, right?
Absolutely.
So I feel that. Go for it.
No, Drew. Sorry, I thought we finished. Go for it.
I'm just saying, when it comes down to allowing best of breed, when we can talk about it right now, the only way for compute, let's say in the cloud, to work best of breed, there's a lot of encoding and decoding to send it over to these purpose-built VMs, if you will. So allowing us to have the best of breed, hopefully running on the same VM or interconnected and not having to use all the compute to compress, decompress, encapsulate, decapsulate, and being able to do that will, one, make the cloud productions much more feasible when it comes down to pricing, but it will also make the latency much more how we perceive latency inside of broadcasting, where hooking up to different machines, it's not seconds or milliseconds off, it's frame based or things like that. That's where I feel it helps out with best of breed in a new software world.
So I echo what you're saying there. I think the MXL we've got to understand is fundamentally the plumbing. It's how to communicate media flows, video, audio, and ancillary between one application and another. So whether that's between two of the same vendor or two different vendors, it doesn't really matter. It's about doing it in the most efficient way to run on a block of COTS, cloud, or multi-node kind of infrastructure. I think the best of breed piece is absolutely there to stay. I think one of the challenges we've had, Andrew, you're talking to a little bit there, is best of breed historically has meant that I have to run independent systems and connect them through traditional linear pipelines. And that fundamentally doesn't make sense in a software-defined space. So having the DMF structure wrapped around MXL is allowing that to happen. A common point of orchestration, a common point of security, a common point of deployment and workflow tools. I think we'll probably come on to that a bit later anyway, but that is really what allows you to pick the right vendors for your workflow together under one combined platform and ecosystem. It's quite often I get the question of, well, AMP is a single vendor system. I'm going to just put out there, it's really not. It is an open ecosystem. That's why we've got maybe 50 to 100 partners kind of in that space already, either connected or native. And actually what MXL is allowing for is more vendors to onboard with that really quickly, Tom and Helio and others. Before we had a fundamentally proprietary code base for that frame cache. Now with MXL, any vendor can develop against MXL and DMF and be natively supported on AMP or any other platform that comes along, and indeed allow those platforms to communicate with each other. And I think that's the thing that's really driving the value for the customer side. It's much easier for a vendor to get return on investment from their development, because making sure it can work everywhere. And for a customer, that then means they get more choice of where and when they run those services.
Remember that best in breed doesn't mean that it doesn't have the strong meaning that it has to have, it absolutely could be a 2-year piece of work to make sure that somebody's got exactly what they need. But also it can be as simple as we're using 1 or 2 vendors. They do a fantastic job end to end, except for we've got a thing here that we need to do. And for good reasons, everybody has, when they produce products, they have different reasons for producing them. And sometimes it just doesn't make sense to have a feature, but you need that, right? So it's as simple as you're able to plug in the gaps, or you're able to then flexibly say, well, look, this part of my workflow is working well, but heard that this one's going to be better. It's got a better flexibility, a better pricing model, whatever. It's actually easier then with MXL. In the same way as using the SDI example, you didn't think about it about the SDI part. That's not part of it's not part of the project, is to consider whether the SDI is going to work. Here, the same to Adam's point, we don't have to think about whether the MXL is going to work. That's the point of the project. That's the aim. And if we have to be spending a long time considering whether the MXL is compatible, then I would suggest there's still more work to be done at that point.
Thanks, Russell. So in terms of hybrid environments, we talked about it a bit, but MXL operates within SMPTE 2110, correct? Correct.
No, it's not.
Well, within it, I would say it's
is it
compatible with 2010 in the sense that you can essentially translate between the two. So you could have 2110 on the switch and be doing MXL on a certain portion, but they are different. MXL is going to be more efficient when you're doing software-based processing. So, but MXL is going to need to bridge into, as Elio showed on one of his slides, there's Dante, there's 2110, there's SRT, all these things feed into that, translate into video frames in the format that MXL uses so that we have common plumbing.
And I do see that they're kind of all interchangeable. And I know Adam and I are about to say the same thing, but I'm going to take the spot.
And the guy,
but they're interchangeable. You want to have a data center technology so that you can have compute inside of your data center, communicate fast and efficiently, and then you want to have your 2110 to help with your long haul distributions and sending it out through your entire facility. That's something that MXL, we're not really trying to replace that, at least yet. But then that's where you kind of have that mix of everything running on an Ethernet cable, everything going into a switch, whether it's MXL, 2110, or IPMX now going over to monitors, right? That was the dream of going to 2110, is having the flexibility that we do now have to do DMF, to do MXL, to do that without switching out hardware.
But we should be clear that MXL hasn't reinvented the rulebook for a number of these things. So the analogy to SMPTE 2110 is somewhat there because fundamentally it is JT&M standard models. We are using flows and grains and those concepts. We're having chunks in the form of either frame rate or audio packet size or whatever actually the vendor wants to implement for that specific piece. And then we're using SMPTE 2059 timing models. So we're leveraging all of the best bits that can be used from those standards in MXL. But to be very clear, it's a memory share rather than packetized transport mechanism. And that brings a huge amount of benefits in terms of using it in a cost space. I would also add, I know we're using the term software defined a lot on this one, but it's not just about software. So what we're finding from a GB perspective, MXL is, yes, it's what you do in COTS, but it's also MXL enabled modular cards. So we can get signals from a modular SDI based signal directly into a multi-node MXL domain. And that allows you to then bridge the gap further between hardware and software to combine the whole thing together under one orchestration.
Yeah, I think we also need to keep in mind that.
Sorry, guys.
Right?
Because I'm here, the only customer. If you have in the market a wave of converting SDI to MXL and vice versa, for many companies it would be a very good product. Because some companies are still using SDI infrastructure instead of ST 2110 or even NDI.
And that's exactly why we're doing it, right? Sorry, Mike, go on.
Yeah. I think it's important to remember that there are going to be, and I think Ellie mentioned this, there's boundaries, right? There's boundaries to MXL. There's SDI, there's 2110. That's a boundary where you need to translate. The other boundary to keep in mind, which I think is important when you mention hybrid, because hybrid can mean a lot of things, but one is ground to cloud, for example. MXL is the fabric protocols that are used, whether it's EFA on AWS or whether it's Rocky ROCE version 2. Those are fundamentally LAN based. And so within a VPC, within a LAN, that works. But when you're going from ground to cloud, a lot of times you don't have the same network, same VPC. And so you're going to have, those are bridges that need to be made and made efficiently. I think there's opportunity there.
Yeah, I want to tack on to what Adam was saying. When we talk about MXL, we are talking about two applications living inside of the same compute. We are moving forward with that to have two different computes that interconnect, and they don't interconnect via 2110. They interconnect using RDMA or libfabric. So if you have FPGA-like devices that would want to go into this MXL land, there are RDMA implementations that you can put on an FPGA, and then it could allow it to contribute to that, let's say, RDMA fabric. So it can be a mix of software and hardware-based solutions, just like Adam was talking about.
And I think that is important because I'm sorry, Tom, I'm going to just reference a Q&A that happens to be in there because it actually does work with this point. So that question from Dominic around the how does this work with ASICs or other chipsets or FPGAs? Fundamentally, one of the grounding rules behind MXL at the initiation of the technical committees was it must be transportable and not locked to any particular vendor, technology host, or otherwise. It needs to be cross-portable to all these different solutions. So absolutely, Drew, it needs to be running on those systems that we typically are familiar with, like Intel and AMD, amongst others. It needs to be run on those ASIC cores, but it also, like we're doing with the ACE3901 card, you can run it on FPGA, and it does integrate as a multi-node system. So that's something that's kind of been shipped in the next few weeks. But that really starts to really question, where do those other linear standards fit in? And the reality is they always still do. You still need SRT, 2110, RISC, whatever you are, to go beyond that initial cluster of compute or systems. What we want to do is that close-knit system there, we want to make it as dense, as compressed, from a cost perspective, and as low latency as possible with one single memory shared domain, which is the MXL domain.
And that's the principle on why it isn't part of 2110. It's because 2110 requires you to think and actually do part of the work of preparing it to go onto a network, cutting things up, adjusting the timing, and then either putting it out onto the network or pretending to. And there's no point in pretending on the same computer to put something on a network just so the other part of the computer can read it. So by not doing any of that, there's immense benefits. And so that's really the thing that makes it not a network protocol, and makes it a way of sharing uncompressed media.
Well, thanks, Russell. I want to get to our audience questions soon, but I want to throw this out. 2110 was introduced probably about maybe 10 years ago. And I'm thinking that all of this stuff that we're talking about now almost seemed kind of obvious back then. What took us so long? Is it about the things we just discussed? The fact that we have not adopted simply 2110 as quickly as was expected?
I would say when it comes down to the software compute, the COTS compute and being able to do what we could do when 2110 was created and what we can do now inside of the compute. I think that's a big major change. I think when 2110 was coming out, saying doing an entire live production on one compute, I think it would probably get laughed out of the room.
I think as a participant in the 2110...
Go for it, Mike.
Sorry. Yeah, I'm in New Zealand, so maybe it's a long lag. I think in terms of 2110, I was involved in that drafting group, so guilty as charged. My analogy would be wheels on luggage. That's an obvious thing, but gee, it took us a long time to invent that. I think in the 2110 drafting group, you had a lot of people from basically an SDI background, and how do we put something like SDI on a network, and so you get to the type of thing that 2110 is. And as you think about it more and you do more in software, different approaches become apparent. So I think it's a natural evolution. Anthony has a question that's talking about is the rigid legislative model of SymphonyAI is simply too slow to survive. I think the consensus model is hard. It takes a long time. 2110, I think we patted ourselves on the back that it was actually fast compared to other, approaches. But the open source approach is focused on an output. You're committing code, and so you get to what is. It's not technically a standard from an ISO perspective, but it's a pseudo standard in the sense that it works, and you get there faster. And I see organizations like SymphonyAI as having a very important role to play. I take the model of the EBU, which is run more on that ISO model, but they've adopted more of a Linux Foundation model of open source. And it doesn't mean that an organization can't, with that expertise, run an open source project. But I think in a software world, open source is a very, very fast and effective way to move things.
All right, thanks.
And I think it will something which is potentially standardized. The standardization is there for the future, and the specifications are here for today. And why don't we do 2110 in this way? Well, actually, the reason MXL's come to be is not because someone said let's do shared memory openly. It's because it's part of a wider, more future-looking brief, the dynamic media facility. And without the promise of other tooling appearing as part of the JTDMF that allows us to use MXL, it's, as we've already said once, it's effectively not very useful, right? We actually need the rest of that project. And I think it's very much, this is of the time, and perhaps it would be nice to have done it a few years ago, but we haven't. The best time to plant a tree is 20 years ago, and the second best is now. So I think that's where we are.
Thanks, Russell. On that note, we do have another question. Does anyone want to take this one on in terms of, is there any concern that because it's an SDK that it won't be adaptable to non-PC form factors, i.e. implementing MXL in FPGA or ASICs? You've done that one.
Adam and I were double duty. Yeah.
Okay. And the first one has been addressed as well, I see. Okay. A couple more questions. In terms of the people working in a broadcast operation, what do they need to know about this? What does the average broadcast tech need to know about this right now, and how is it going to impact their lives over the next couple of years?
Well, I think
I'll throw out. Go for it, Mr. New Zealand. No, it's okay.
Okay. Yeah, I think one of the goals, especially as we look at the other layers of DMF stack, is that they should ideally we're succeed when they know as little as possible or can do things as quickly as possible without having to get in the weeds. And so that's because of that. For me, it's a tough question to answer. Except that we need to make it very, very simple. All the things that Elio showed in his things about DevOps, all important, foundational. But when you get to the operator level, it should be really easy to run. And that's when we know we've succeeded.
Right.
Yeah, I was going to say, I mean, what we're doing is standard IT processes, right? It's been around forever and video is adapting to it. So using shared memory, using RDMA, things like that. There are classes out there today that will teach you about these technologies that we're using. And that's kind of the point of MXL, right? Is not to reinvent the wheel, is to use technologies that have been out there forever. So as Mike said, I mean, the greatest thing that could happen is that you hit start and it just runs and nobody cares and nobody knows what's happening in the background. But if you really want to dive into it, look into shared memory concepts and look into RDMA networking and stuff like that, I would imagine.
All right, a couple more minutes. One question, how do you troubleshoot MXL after it has been integrated?
You think
We're still troubleshooting that ourselves.
I think
as
one
part
of
the project, we're creating some test. Well, we have to test it, right? So there's going to be some tooling that comes out of that. Now, the type of tooling that you need early on is very different to what you need later, but that's where vendors step in, right? And we've seen that with 2110, it's been quite successful. So the real question is, what are the problems that we're going to see? And I'm not sure we know all of the answers yet. And I think part of putting it together is going to teach us that, whether it's more about tools to monitor where the MXF flows are and what their IDs are, to find ones that have been lost and orphaned, or whether it's going to be more about analyzing the memory use and where ring buffers are or RDMI. Some of this is going to exist right already in the wider IT industry, and that's the whole point of using this. So it's a matter of making sure that we have scoured the industry for the IT industry for all of the tooling that they have, and then we see where that gap is. Where is the gap which perhaps they're not measuring that there's a new piece of information every 16 milliseconds or whatever. Those kind of video and audio answers are the extra bits of work that we need to put in, not only as the project, but then once people are using the project, then naturally we'll see those tools kind of come to market.
Yeah,
Thanks.
completely. I think the other kind of extension to that, off the back of what you were saying, Drew, is it is relatively new. We are still developing these services. We've got the release candidate one that went out at Christmas. That's allowing us to release our kind of MXL gateways production and others as well. So that's available in the platform. But the key thing is that as DMF gets defined for how you do flow discovery, how you do flow routing, and those kind of topics, that's actually where most of the kind of triage is going to take place, I think, to your point, Russell, around understanding what we don't know today, if that makes sense. So probably if we revisit this at NAB, I think things are going to progress a lot. It's moving really quickly every week. DMF itself is probably months, if not a couple of years away from being fully defined, and we're just going to iterate as we go. And I think that the important piece is that for any customers using our select vendor systems, those systems will, by the nature of them being software defined, iterate and grow and kind of be future proof to kind of take on the learnings that DMF and these testing tools have kind of automatically through those kind of SaaS-based systems.
All right.
And I would say foundational. Oh,
go ahead.
You need to go. No, he owns the customer, so go ahead and ask.
Helio, do you want to? I mean, you obviously have had to address this already, correct?
Yeah, sure. But I was thinking about what all was said here. But of course, but I think it's two parts. It's about two parts. The first part will be a job for the DevOps in terms of the infrastructure, the computing. But of course, we need like a a vendor capable to have a very stable waveform to check if the latency of the signal, if the signal is not varying during the time, if they are respecting the SDK. It's something very new, right? It's not so easy as we have a formal waveform in order to inspect if the MXL flow is good or not.
Right.
Yeah.
No, that
I was just gonna say, like Ilya and Adam are pointing to, there's going to be some MXL specific tools that we need, in addition to the fundamental kind of network and compute things like what's my network doing, what's happening on my host, are my containers healthy? All of that foundational stuff needs to be there, plus some MXL specific tools, which we need to come up with.
All right. Thanks, Mike. We have reached the top of the hour, and I want to wrap this up with one quick question. Obviously, we have a big show coming up in a couple months. What do you see as the, obviously, there was a big topic at IBC. What do you see in terms of plans for NAB, in terms of what you guys will be talking about and what you've heard through the grapevine? Helio?
In terms of the NAB, we expect to see the development of all vendors about it. But of course, as soon as you have a quickly development and we can show to us, Global is very open to see it, or even in NAB or after. It's up to you guys. We are expecting to see this running very well in the end of the year, but of course, if you have any news to show me anything, it's okay. It's okay.
All right.
For me.
Thank you. Adam?
Yeah, so I mean, in the context of MXL and software defined, we're releasing or working with our partners to release a number of released applications that are MXL native on AMP. So as I say, we've already got the gateways in place. With flow discovery and level of routing control. That's going to go to a whole new level by NAB. It's moving really quickly, and we've got 5 different vendors that we should be releasing at the show as well. So exciting times.
Mike?
Yeah, we're very excited about adding additional partners. Some of them are on this call with MXL integrations. And I think just in a general sense in the industry, if you look at the progress since the fall of 24 until now, and what happened at IBC, I think you'll see more vendors interoperating. The MXL, as Adam said, has a release candidate. So I think you'll see some pretty fast progression.
Russell?
Oh, hi there. Yeah, well, look, NAB is going to be all about the advances, and the advances are, of course, we're developing our own implementation of MXL. That's part of our work in the project. We're also taking a leading role in part of the DMF work to work out synchronization. So all of this is going to start to come together. Most of the benefit, I think, is going to be the continued interop testing, which is happening between now and NAB, and really getting together and seeing the lay of the land. Right, we're all trying our hardest to work widely, collaborate, but we can't see everything that everybody's doing. And so I think we're really looking forward, not only bringing our updates and testing to NAB. But also finding out where it's fitting and talking to people like Helio, because it's the use cases which are going to drive what we need to do and the priorities. And so there's definitely some use cases that we know now, obviously, but I think there's plenty more, and we're only just scratching the surface.
All right. Thank you, Russell. And Drew, you have the last word.
All right, cool. I can say anything. So at IBC, we had the multi-viewer, and it was showing 4 vendors intercommunicating with each other. My hope is that at NAB this year, with having that RC out, is that we could have other vendors contribute, maybe have a bigger multi-viewer. But my big thing that we want to show at NAB is really how all the vendors can work together inside of MXL. Our products that are using MXL are not released yet. We will show little code snippets very similar to what you saw at IBC. But our main goal is to make sure all the vendors can really all work together inside of that single ecosystem, and us helping that out.
All right. Well, thank you, Drew. That's all the time we have for today. I want to ask you to all join me in thanking our expert panelists, Adam Marshall, Mike Kronk, Drew Martin, Russell Trafford-Jones, and Helio Efrazinho from TV Global. Thank you again for all your valuable insight. For the audience, if you joined us late, please note that this webinar will be available on demand soon. Also, if you haven't already, I would encourage you to check out the first webinar in this two-part series led by TVB Europe's Jenny Priestley. You can find the registration info at www.tvtechnology.com and click on the webinar calendar on the trending bar. We value your feedback as well, so please drop us a line at tvtechnology@futurenet.com with your thoughts. Again, I'm Tom Butts for TV Tech. Thank you for joining us and have a great day.